Okay, I got some examples of rational expressions here. The first thing you have to remember when you're dealing with a rational expression or a fraction that you have to reduce is Duran rule. And this is my special rule. You always put a grouping symbol or a parenthesis around the top and the bottom separately. Why? Because you cannot reduce anything involved in a plus or minus on the top of the fraction or the bottom. You must factor first. So the only way I can reduce is if I have a complete factor the same on the top and the bottom, then I can reduce. If these two were the same, I could reduce them both and put equals 1 over 1. But they're not the same. So now what I do is I look for ways to factor, and I notice there's a common factor on the top. So I could call that x times x minus 2. What about the bottom? Did you notice that's a difference of 2 squares? X minus 2 times x plus 2. Now that the fraction is factored, you can reduce if you see some common factors. You see anything? Oh, I do. How about this with this? Final answer, x over x plus 2. Should I cancel those x's? I hope not. What's my rule? Grouping symbols. Do I have a group like that on the top? No. How about this one? I don't really need a grouping symbol on this, but let's put one just for spite here. Do I have exactly the same parenthesis group on the bottom? No. I cannot cross out that x with that x. So, final answer right there. So, remember, grouping symbols before you do anything in terms of reducing a fraction. All right, let's do another example. It's not even a fraction. That's what you think. Watch this. You see that exponent -1? We learned about negative exponents the other day. Let's rewrite this. Nice thing, this one has my grouping symbols already. So when I rewrite it, I make sure I keep them. I'm going to put this on the bottom of the fraction. Do you remember why? Remember negative exponents, if they move through the fraction bar, become positive exponents. I don't need that one there anymore. Now, can I reduce that x squared with that x squared? Hope you said no. All right, what do? I have to factor. Okay, well, common factor, they all have an x, so let's take the x out first. And then I have 3 minus 5x minus 2x squared. All right, let's factor the bottom. No common factor. I wonder if it will factor into 2 parentheses. Okay, so now we have the 2 parentheses ready to factor the bottom, but that's not as easy to factor as you might think, because there's a couple possibilities for factoring that 6. So let's get 2 test parentheses over here. I could do 6x and 1x, or 2x and 3x. There's not a lot of choices for the 1. I could use +1 and +1 or -1 and -1. I hope you noticed it because the center has a minus. We're going to use -1 and -1. Now, can this factoring problem have 2 answers? I hope you said no. All right, so we need to check to make sure we get a 5 in the middle. So check these two, -1x, check these two, -6x adds up to -7. That doesn't work. This one must be the one, but let's check it. -3x, multiply these two, -2x, add up to -5x. Whoa, that's what I'm looking for. Okay, so this factors 2x minus 1 and 3x minus 1. You know, that factors 2. Oh, again. All right, let's go. Here, I could use 3 and 1. factors of minus 2 could be positive 1 and minus 2 or negative 1 and minus 2. We'd better put two test parentheses here. 3 and 1 again. Okay, so we're factoring this for minus 2x squared. I said I could have minus 1x and plus 2x. Or I could have plus 1x and minus 2x. What do I need in the middle? I need a negative 5. Let's see. 1 times 1 minus 1x, 3 times 2 plus 6x, that's a plus 5. This one's going to work. I'll test it just for spite here. Plus 1x minus 6x, add them, minus 5x. There's our answer. So, now we have our factoring for this parenthesis. So, let's get another sheet here. All right. Okay, so now that we figured out all of our factoring, let's rewrite our fraction here. So, we had an x for the top because we had taken an x out of all of that. And then we figured out the two parentheses for the top were 3x plus 3 plus 1x and 1 minus 2x. So now we have all the factors of the top, and we did some testing on this one on the bottom, and we found out that 2x minus 1 and 3x minus 1 gave us the factoring for the bottom. Now I look and I see if there's anything the same that I can reduce out of this. And this one's pretty tricky. Nothing's the same. Then I notice, hey, these are backwards of each other. You can't just go changing things, but you know, minus 1 times minus 1 is equal to 1. So I can multiply this by 2 minus 1s, or this one by 2 minus 1s, and then be able to reduce it. So I'm going to use my 2 minus 1s up here. So one of them is going to make this 2x minus 1. And the other minus 1 that I'm going to use, I'll just put out in front here. I have to always use 2. Okay, now I can reduce here with here. Final answer, minus x times 3 plus x over 3x minus 1. This one's tempting. Looks pretty close, but it doesn't quite make it. All right.